There we go. See, now YouTube's working, dude. These people, I swear, dude. Okay, cool. Let's see. News. Do we have any news? I guess it's Tuesday. One more day left in the streaming week for me. I was trying to get a guest for our AMA podcast on Friday. I might have someone. It was this cool guy. He was actually a college prep person. His name's the College Guru. He was actually in this, I don't know if you guys have seen this thing on Netflix. It was called Varsity Blues. I'll show you guys if I haven't heard about it. It was basically this massive, like, scandal they had where college admissions people were doing, like, pay for play to get people into, like, Harvard and stuff. This guy's name was Rick Singer. No, it wasn't Varsity Blues. Or was it? Netflix. Operation Varsity Blues. Okay, never mind. It's called Operation. Varsity Blues is a different thing. But yeah. It was a big college admissions scandal where some celebrities got caught. Basically, they would pay this guy named Rick Singer to pretend that their kids were, like, athletes and then get them into Harvard on, like, athletic scholarships. Like, they would Photoshop pictures of them on a rowboat or something. Anyway, it was pretty good. But one of the guys I met through some tech mixer here in LA, I think was on this. Let me think. His name is Perry Kalmus. Yeah, there we go. All right, cool. Yeah, and he's got this thing called Kala or Akala, which is, I guess, a cheaper way. Because a lot of times, I even get this when students are trying to get into college. If I've been tutoring the student for a while, throughout high school, the parents will ask me to help them with their college apps, which I don't necessarily specialize in doing this. I don't seek out jobs in college admissions, mainly because it's a fucking rat race is what it is. And I don't know, it feels kind of dirty to do it. But they do, usually it's incredibly lucrative. Some tutors will charge like $2,000 or $3,000 to get people into college. They, I think, do a really much more affordable thing. I think it's like $70 a month or something, but it's supposed to like help you with your college apps. Because it can be daunting, especially, some of you students, your parents didn't go to college, or you don't really know anyone else that went to college, or you don't have older siblings that went through the process. To do this all on your own can be a little scary at times. So it helps to have someone who can kind of guide you and be like, hey, yeah, you should do this or you shouldn't do this, or like take a look at your personal statement. I think some of you students have college counselors. Is that a thing in high school? Do you guys still have like college counselors, like guidance counselors? Also, I think the lo-fi rate is a little too loud. Turn it down. There we go. But that can be useful. I always tell people I'm happy to give free college advice. Yeah, you have guidance counselors? Okay, cool. Hopefully they're useful. I hear different opinions on that. I hear some students say that like my college counselor is like fucking useless. But they should like be pointing you in the right direction and like getting you prepared to apply to college if you want to. I'm starting to back away from this belief that everyone should go to college. Because I'm starting to see that it's kind of been a push by these universities as a moneymaker, which I agree, education is great, higher education is awesome, but I think some colleges are getting really pushy with trying to get kids to enroll when they don't really want to be there. Or they would do much better at something else, like say a trade school or an apprenticeship or something. I don't think everyone has to go to college anymore. I'll probably get yelled at for that, but anyways, let's see. We got some questions today. Looks like Rainy has one. It says I have been stuck because of a fish. Uh-oh. What's up, Sam? Good to see you, bro. I'll drink my Erewhon protein shake for you. Sam knows about Erewhon. I bet you do. Place is ridiculously overpriced. Yeah. I remember I went with a girl to, like, go get breakfast or something. We got, like, 2 breakfast burritos, a juice each, and I think she got some chips and salsa, and it was, like, $80. I was like, what? $80? For breakfast? For 2? And it was at a grocery store. I understand if you're going out to eat somewhere, like, really nice, like, $80 isn't that bad for 2 people, you know, especially if there's some drinks involved. But yeah, it's a notoriously expensive grocery store in Los Angeles. I think it's only in Los Angeles too. But all their stuff is delicious. That is the problem. You know, it is expensive, but it's really tasty. I still won't stop at like Gelson's because of Gelson's is like not worth it. Gelson's is overpriced, but not worth it. I'll say Erewhon is overpriced, but is like kind of worth it. Shantrick says, hey, I had a question. There's a puzzle question on a 2022 Pascal contest. I don't understand. It's question 25. Could you try and explain it? Yeah, we could take a look at it. Do you have a link to the question? That would help me out immensely. Otherwise, I can go find it. Let me see. 2022 Pascal contest. Question 25. Oh, another Canadians. Yeah, you guys, or it's University of Waterloo. You know what's funny? Oh, thank you. One of our friends who also streams, I think actually runs this exam, or he grades it or something. I'll give a shout out to him. But his name is Penn Center. Can I shout out Penn Center? Yeah, there we go. Yeah, so Penn Center, he's a friend of ours. And he's from Canada, but I think he works at the University of Waterloo, or he's close to it or something. But he does stuff here. All right, let's see. Oh, okay. This is the question. I'm guessing, do they post the solutions for these? Because a lot of times these questions don't really test like how good you are at math. They just test whether you know like some small little trick to solve them. So if they have a solution, I can probably help explain the solution. Probably the better way to do it. There is a solution? Okay, let me find it. One sec. Just so, I mean, I'll take a stab at it, but then I'll just look at the solutions. Oh, nice. Shantrix, you're so nice. I love this. Just give me links like this. Great. Oh God, what the fuck? What the hell is the solution already? Oh Christ. Okay. Yeah, dude, if this is the how the fuck are you expected to get this as a high school student? But okay. Whatever. I'll look at it. Okay. A hexagonal prism has a height of 165. Its 2 hexagonal faces are regular hexagons with sides of 30 centimeters. Its other 6 faces. All right, cool. All right, so I'm gonna write some numbers. So this is well, let's use a different color. This height here is 165. And then the side lengths are 30. Okay. A fly and an ant start at point X at the bottom of the face and travel to point Y at the top of the face. The fly flies directly along the shortest route. Okay, so the fly's doing this. Okay. That's the, well, here, let's use a blue color for the fly. Say this is the fly. Well. Okay. This is the fly. The ant crawls around the outside of the prism along a path of constant slope, so that it winds around the prism exactly n plus 1/2 times. Oh, okay. Oh, I see. So the ant is like doing this. Like spiraling, I guess, yeah? Okay. And it goes n plus 1/2 times, yeah, because it's got to make half a rotation to get to y. Okay, that's fine. The distance crawled by the ant is 20 times the distance flown by the fly. What is the smallest possible value then? Okay. Probably good to figure out what the distance of the fly is first. Like, we could do that, yeah. So I gotta know, like, distances and bases and stuff, right? Okay. Let me look at my hexagon. Geometry. Yeah, that's what I want to see. Oh, there's 60s. Oh, that's fun. That's really cool, actually. I like that. Nope. Okay. So to get the fly's distance, right? We're going to kind of make like a triangle. Like this. Yeah. Where I want to know what this distance is. I know the height here. The height here, right, is 165. That's easy. And then I just need to know this distance. It's like from here to here. Each one of these sides is 30. And if this is 60 degrees, doesn't mean they're all equilateral, right? So this is 30, this is 30. That's cool. Okay. So this distance is 60, right? So then, distance of the fly is equal to the square root of 60 squared plus 165 squared. Yeah? I think that's a pretty simple thing to do, yeah? That's not like too hard. One second, let me pull my calculator out. They probably want like an exact value for this, but I'm gonna get a decimal because I'm feeling approximate today. Okay, where's my calculator? Calculator. Okay, so square root of 60 squared plus 165 squared. That gets me a distance of 175.57. Okay. Cool. And then we want to be 20 times that. All right. So now let's think about... I wonder if I want to use calculus for this. I don't think I need to. Okay. So it goes up at a constant slope, right? So that means... I wonder if I want to do this as in the terms of like an angle. Yeah, right? Yeah, let me... I like the angle idea, right? So I'm gonna call this like an angle theta. They do it as a triangle. Yeah. Let me see if I can do it with theta, and then it'll probably like pull out anyways. Because to me, when I think about the constant slope, I want that to be a constant angle that is traveling around the whole time. Okay. So this is 30. Okay, and then this is... so all 6 sides are the base of the triangle. The height is 165. And the slope is the distance. Sure. Oh, I see what you're saying. Right, so, yeah, okay. Yeah. Okay, I like that. That's actually kind of a cool idea. Yeah, so he's saying that, okay, you eventually have to travel 165 up. And then this is going to be your total distance. But the amount you do this, okay, so a revolution, so yeah, let's write down some things here. So like 1 revolution is equal to 180 centimeters, right? Like to go around once is 180 centimeters here. So nice. This is n plus 1/2 times 180. Yeah, no, I get it. Yeah, no, that's pretty cool. N times 1/2. N plus 1/2 times 180. Right? Oh. This isn't very hard. What's up, nerds? Yo, what's up, dog? Oh, thanks for the follow, Nintendo Pharmacon. That's cool. Okay, because, right, if you go around 1 time, right, then, or you have to go around 1.5 times. So you could say, like, n equals 0. Okay. Oh, this isn't bad. Wait, why is their solution so, like, complicated? All right, whatever. So total distance is just equal to n plus 1/2, 180 squared plus 165 squared, right? And then square root that. And then I want that to be equal to 20 times the distance flown by the fly, which was this. So 20 square root of 60 squared plus 165 squared. I guess you could square both sides, right? So this is 180n plus 90 squared plus 165 squared is equal to 400. And then that's 60 squared plus 165 squared. I mean, this isn't that bad though, right? Is this not that bad? So what, 400? Do you have to do this? Inequalities? Well, you don't need inequalities, right? Oh. I see what you're saying. Oh, because you... Oh, Well, wait a minute. I think you just set it equal to 20. Because we say that the distance crawled by the ant is more than 20. Because it could be more, right? This could be like 100 times if the ant just like decreases its slope by a lot. I think if you set it equal to 20, that's the breaking point. That's the minimum. Right? I don't think I'm crazy here. Alright, minus 165. Well, let's see. Let's see if I get the right answer. If I don't, then whatever. Divide by that, and then, square root all that, and then subtract 90, and then divide by 180. This is unfortunately, like, not anything nice. Wow, what's up, Milk? Thanks for the follow, dog. So let's see. 60 squared plus 165 squared. Ah, fuck. Equals that times 400 minus 165 squared. Square root it. Okay. Subtract it from 90. Divide by 180. So n has to be equal to 18.98. So n equals 19. Was that the answer? Yeah, 19. Okay, cool. Yeah, and you need a calculator for this, dog. You can't do this by hand. Yeah, so again, don't worry about the inequality, Shank Tricks. Yeah, don't worry about the inequality. Just set it equal to, because that's going to be the minimum. That's the minimum amount of times it can go around. Because if the distance was more than 20 times, then it would have to go around more times. Then the distance would be longer. Sorry. If the amount of times you went around was more than 20, then the distance is going to be longer. Because that means you have less of a slope. This actually wasn't that bad of a question. The solution just looks like super scary, dude. Like, I would get bugged by I'd be like, no. That solution looks so much more difficult than it needs to be. Yeah. But I like this. This was a cool idea. I think this is the crux. Once you realize this is the trick, which honestly wasn't that bad, then it's just solving this. And then, well, you also need to know that this is a triangle as well. Does that make more sense, Shank Tricks, or let me know where did you get caught up? Where was it difficult for you? Well, yeah, I mean, the solution is like, yeah, they write it as like 6n plus 3 times 30. I just multiplied that by 180. Right? I just distributed this. That's why I got the let me see. Yeah, so we got this. We got the f is equal to this. We got that. That was fine. I want to see why the hell did they do this? Oh, okay. Since the ant passes 6n plus 3 faces. It's kind of weird. I would have just said it's n plus 1/2 times 6. Yeah. Unwrapping I mean, and that's what we did here. That's what I did. So you have to do n plus 1 revolutions, horizontal distance of 30 in the triangle. But then your vertical distance is always 165. So it's just doing enough of those to then get this equal to 20 times what the fly distance was. Yeah, it's actually not that bad of a question. This just looks gross. And yeah, don't worry about the inequality. Just set it equal to. This is a common thing we'll do in physics a lot of times. They'll ask, like, for instance, like, what's the highest angle you can have the inclined plane before the block falls down the plane? And what you always do is you always set that angle such that the forces are equal. Like, the force pulling it down is equal to the force of friction keeping it up. I know technically it's like it's the breaking point. It's like right before the force pulling it down is greater than the force of friction keeping it up. But if you just set them equal to each other, then you know it's, you know, it has to, and for here on the n had to be a whole number too, right? So when we did this, yeah, I got like 18.98, right? That's what I got on the calculator. Yeah, I got 18.98. But I know that's the lowest amount I have to do, and I can't do 0.98 of a revolution, or n can't be 0.98. So you have to make that equal to 19 because it has to be the next whole number up. Yeah, it's a cool question. I actually like these. Thanks for showing me these. What is Lando saying? Twitter, x.com. Yeah. Very cool, man. I appreciate it. If you have any other questions about those, yeah, please let me know. I'd love to run through them. Are you studying for a competition happening? Like when's the 2025 Waterloo exam? Oh, it's in February? Oh, that's cool. Nice. Here, let's see what our next question is. It comes from, wow. Someone uploaded a ridiculously high-resolution image. Okay, there we go. Wow. This looks like physics. I think it's a physics question. We're talking about refractive index. I don't know if you guys have ever noticed this before. Have you ever done, like, here, what is it? If you ever, like, take a pencil, for instance, and you put it in a cup of water like this, it'll look like it's broken. And the reason this happens is because water has a different index of refraction than air does. You may be wondering, like, what the fuck is this index of refraction thing you speak about? It has to do with that light travels at different speeds in different mediums. And so, when you have boundaries between, like, air and water, you get like a bending of that light. That's also how like rainbows and stuff work. Yeah, nature takes the shortest path. Yeah, that's kind of, yeah, I think so. Yeah, it has to do with this. So yeah, yeah, it has to do with like density and stuff, right? Yeah. So it bends here. But if you look at it on both sides, it actually comes out at the same angle eventually. But where's the geometry for this? Yeah, this is always what I gotta like. This is an 8th grade question? Oh, really? Well, that's pretty advanced for 8th grade. Yeah. And it has to do with, yeah, because when we look at, for instance, with our eye and whatnot, we see like straight is what we do. But it turns out that, yeah, this is the difference of the virtual image versus the real image. Because where the end of this ruler actually is down here in order for it to come up at an angle here so that it bends and looks like it would have been back here. This is called optics, is what this is. This is kind of a tricky concept, honestly, in physics. Let me see if I can get a better diagram of that. Yeah, here we go. This is a pretty good one. And then here's like the picture that they, where is it? Yeah, this is why it looks bent. Watch. Here. Push that in. And there we go. There we go. Yeah. So yeah, this is called refraction. Yo, Wagwan equity. Good dude. Yeah. So when you're looking down at a pencil, the pencil is really like this, okay? But what ends up happening is that because of how like light bends, where this end of the pencil is when it comes up looks like it's technically here if we were to look like straight through the water. And that's why you end up getting this. It kind of looks like it's bent. I wonder if that is involved with this question, though, because it says, okay, cool. So we do have a refractive index. Okay. So here's the rule. It's called Snell's law. which says that n1 sine theta 1 is equal to n2 sine theta 2. Oh, you got a video on it? Oh, thanks, Shantrix. Let's see. Let's check it out.
Who's coming in the driveway?
It's just advertisement. Dad, my dad came back with the milk.
With that, let's rewrite the principle into its modern form. Starting with
Oh, Veritasium?
which is the sum
I love
of mass
Veritasium.
times velocity times distance plus
Where-
any variation in
where is
time.
the-
Then if you were to change it a little bit by say extra
Veritasium, man. You know, I applied for one of their jobs.
everyone
I applied to
is and
Veritasium.
travels another 6 meters at 3.
Oh, where's the...
immediately
Wait, where's the fast descent for Maz, Bernoulli's? Well, actually, I think they put part of the topics here. Here we go. Oh, go to 521. Okay. Oh, yeah, here we go. Yeah, okay, here we go. Oh, perfect. Yeah, this is a great video of it. Yeah, nice.
is equal to a constant n,
Yes.
which depends on the nature of the two media. This came to be known as
Yeah,
Snell's law.
Snell's law.
But no one knew why it worked. That is, until 1657.
So another great mathematician enters our story at this point. This is Pierre Fermat.
Fermat.
By day,
Fermat's
he
last
was
theorem.
a judge, but at night he'd come home and hang out with his wife and kids, and then do what he really loved the most, which was work on math for fun.
He worked on math for
He mostly
fun.
worked in pure math, but at one point he got interested in the question of why does light obey this principle of refraction?
Yeah. See how it comes in, it
And
bends,
he
and it
thought
bends again?
Maybe Hero of Alexandria was on the right track, but it's not distance that is being minimized, but rather time.
Uh-huh.
But to see if this was true for refraction would be difficult. He would have to work out every possible path light could take by varying the point where it intersects the boundary and compute the time for each. And then show that light takes the path for which the total travel time is the shortest.
That's cool.
He doesn't know how to solve it, and he worries that it's going to come out complicated even if he could solve it.
But then it's a fucking
So
sine
He's
graph.
not going to do it.
Wow. I didn't know this,
'Cause he wasn't
Shantrix.
super interested in physics, actually. But anyway, years go by. He gets interested in it 5 years later and tries to solve it. And then he does solve it. And he shows that Snell's law actually pops out as the minimizing path.
Oh, that's
for
super
light.
cool. Yeah, so... yeah. And why this is actually really... Thanks for showing me that, Shantrix. Yeah, where did I have the graph of, like, slow versus fast? Was it here? No. Where do I have it? No, one sec. I had it. Yeah, okay, this is the picture I wanted. One sec. No, not the lo-fi music. There we go, okay. Yeah, it has to do with this, right? So, when you go through materials that are slower, such as water, yeah, very cool. It could take a couple paths, like, for instance, to get to here, right? One sec. So, it could try to spend the least time through here, because it's slow, and then it would, but then it would have a greater distance it would have to travel here. Versus, it could spend the most amount of time in the slow, and then have the shortest distance to travel in the fast. Right, and so there is some, like, nice, happy medium in between, where you're not spending the most or the least time in the slow medium, but you're also not having the most that you have to catch up with at the end. The speed of light would go to C over U, because light's a wave, right? Frequency... Yeah, frequency wouldn't change, but the speed in the medium does. Yeah. And you know what's cool with the wavelength changing, actually? That's why, for instance, you get prisms. That's why prisms make rainbows and stuff. Was it prism, rainbow? Yeah, exactly. It's because light, so white light, for instance, is composed of many different wavelengths, all, like, summed together, okay? And so based on that wavelength, it gets, like, kind of separated out here. Yeah, gets, what is it? The fastest one is probably, like, violet. You can prove this using YDSC. What's YDSC? Oh, Young's double slit. Oh, yes. Yeah. Young's double slit experiment. Yeah. Yeah, that and, what is it? The, oh, man. The photoelectric effect. Those are the two things that prove that light is both a particle and a wave at the same time. It's very cool stuff, actually. Yeah. So wait, let's see how this all goes back to, like, what this question was. This was the original question that one of the students was asking. And then here, let me get a diagram of Snell's law real quick. Yeah. I kind of like this. Is a decent picture. Young's, is he Chinese? No, he's not Chinese. I don't think he is. And I think it's Yongs. Yeah, I don't think it's spelled Young. Yeah, this is the original question. Okay. So it says, a fish looks from within the water of a refractive index 4/3 and sees the outside world through a circular horizon. Kind of confused what the circular horizon means. Does that mean it's like a circle? Like, what does it mean, like, circular horizon? I feel like we have... we got fishy. And if the fish is 0.7 centimeter or square root of 7, yeah, I think like he sees like this. What does he? I guess. Yeah. Okay. Because it's seeing like part of it is above the water, part of it's below the water. So like maybe the fish is seeing like this. Is that kind of like what we think of like a circular horizon? And so we're saying that the fish is square root of 7 below. What would the radius of the circular horizon be? So maybe something like this, right? Okay, so I know that this will be like theta 1. Or, no, that's wrong. Sorry, this would be theta 1, right? And then this would be theta 2. IG equals H over square root RI squared minus 1. Wait, where are we getting all that from? Well, I assume that this is the I assume this is the radius of the horizon underneath, and then we want to figure out what the radius of the horizon is above. Yeah, using tan and theta. Yeah, I guess so. Okay. Yeah, exactly. Yeah, okay. Okay, so N1 is 4/3. Okay, so we know 4/3 sine theta 1 is equal to, the index of refraction for air is just 1. So this is 1. Sine theta 2. Yeah, you're all good, dude. But then this is, square root of 7 is based on cosine, right? I guess this is pi minus theta 1, right? And so then this is pi minus theta 2. Oh, pi over 2. Yeah, sorry, bro. You right. My mistake. You get a save freak, Bob. I'm gonna give you a save for that. Yeah, good save. Oh, why is Enigma bot not working? I gotta talk to Enigma about that. Damn. Okay, find some time, yeah. Okay. I feel like I need more information. Like, is this the radius? Is this the radius of... Is this the circular horizon? You think you got 100%? Let me know. Do you assume this distance is the same? Okay, in order for the fish to see... Oh, total internal reflection to happen. Oh. Okay. Yeah, because I was like, I need the angle then, right? Okay, so... Total internal refraction.
Nice.
Oh, thanks for the follow, Larson. Sup, Brian? Brian in here too. Theta 2 will be 90 degrees. Correct. Okay. I agree with that. So, okay. So 4/3 sine theta 1 is equal to 1. Right, good. Okay. So theta 1. Yeah, right. Which is when theta 2 is equal to pi over 2. Okay, I agree with that. So sine theta 1 is equal to 3/4. Tangent theta 1 is r over h. Uh-huh. Well, let's think of that. One sec. Okay, so...
Nice.
Oh, so this is what you're calling the... This is R. This is the radius. I've just never seen this, bro. Like, the radius of the circular horizon. That's kind of weird. I get it, though. I guess that, like, this makes like a circle or something. Yeah, okay. All right. Then, yeah, tangent of theta 1 is opposite, so that's r over h, which equals r over the square root of 7. Okay. So r equals square root of 7. Tangent tangent of... Oh, this is cool, but this is a 3, 4, 5. No, it's not. Damn it. Oh, it's close. I really wanted it to be. Okay. Gotta build a triangle. That's unfortunate.
I have arrived. Fear me.
Oh, what's up, Sensation? Oh, good to see you, dude. I see you now. We're doing some triangles. Triangulars. Ugh.
So you're doing some 3D geometry.
Yeah, this is like kind of 3D, I guess. This is opposite. Hypotenuse. So what is this? Yeah, this would be root 7 then, right? Because 3 squared plus square root of 7 squared equals 4 squared. Okay, cool. So this is theta 1. Yes. So tangent is opposite over adjacent. Oh, so r just literally equals 3? Cool. Answer's 3 centimeters. Wow, look at that. Wow, excellent. Nice. Poggers! That's dope. Yeah, thanks Freak Bob for the help on that one. That was kind of a hard one. Poggers. We learned a lot there. I learned about, yeah, answer's 3. Wow. Wow. What's going on your side of the pond, Sensation? What's the crack?
Just lots of helicopters landing just now.
Why are there helicopters landing? Is World War III starting already? Without me? What?
I have no idea. There's no information.
Oh, okay. What does the UK use for helicopters? Do they use like the American Apaches and stuff, or like what?
For which purpose?
I don't know, like military stuff.
I couldn't tell you.
Do you guys have your own helicopters, or is it all like American stuff?
Yeah. Seeing as we invented the helicopter.
Did the Brits really invent the helicopter? Really?
Scottish people pretty much have invented everything that you can think of.
Oh, that's cool. I didn't know that. You know what?
Like, you know, the light bulb, the radio, the television, the internet.
Yeah, Alexander. He was a Scotsman. Alexander Bell, right? Was he Scottish?
Yeah. See, Alexander Graham Bell, John Logie Baird. Penicillin, I was Alexander Fleming.
Loki, I want to move to Europe. Loki, Freak Bob, where you at? Where you at right now, dude? Are you in America?
Yeah, you don't want to move to Europe.
Never Scottish. They are British. Yo, someone named Magnetar, dude, wants to fight you, dude. Sensation. They're saying the Scots are Brits.
No, we were enslaved by the English, and
we were enslaved by the
became a whole thing.
That's the
Look,
whole.
It's only black people that get enslaved. It's like, no, we were enslaved for thousands of years by the English.
That's the whole William Wallace thing, isn't it?
Well, it goes way back before that.
Goes way back. It says.
Pretty much the fall of the Roman Empire.
But who are the Brits then? Were they the Romans? How'd that work out?
The Bretons were northern French.
Ah, northern French. The Britons. Shadrick says, I want to move to Holland and just jump and run in the tulip fields. They're probably pretty.
Oh, somebody likes his heroin.
Freak Bob says, I'm in a third world country right now. I might get a green card if I do my MS MBA. Yeah. Oh yeah. Education's a good way to like get out of poverty. For sure, man. We are always looking for skilled laborers. Although I don't know if like coding is a viable thing anymore. Isn't there like an insane like excess of like people in India who can code, and we're just like, well, we don't really need them anymore.
Yeah, in Hindi.
Oh, I see. I have to know English. Oh.
As weird as that sounds, as weird as that is, it's like you still need to be able to like write the manuals in English.
Yeah, you still be able to communicate during the board meetings and stuff. What's up, Maxwell? Weren't the British from Northwest Germany? Were they? Sensation?
The Saxons were.
Saxons. There we go. Anglo-Saxons.
It gets kind of complicated. There's the Celts, and then the Romans come, and then everybody intermixes, and all the Celts sort of go towards Wales, Ireland, and Scotland, and sort of stay there.
Oh,
And then come the Normans and the Saxons and the Bretons and everybody else.
All I know is about
They
the
should-
good old United States of America, dude. 1776, baby. Never forget.
That's dope.
All complaining about a 2% tax on tea, and now look at you.
Yeah, look at our tax rates now. Yeah, look at the taxation without representation right now, dude. No one's doing shit.
At
Even
least you get
Singapore-
representation.
Even Singapore sounds cool. Oh yeah. Well, yeah. Wait, Singapore has a bunch of really strict rules, right? Like you can't chew gum there or something.
I don't know that one.
I've never been to Singapore. A lot of
yeah, Singapore's one of those countries where you can't open the melons. What do you call them?
Oh, the
Oh, God damn
durians. The durians.
Yeah.
Yeah, durians are illegal. Since smell like rotting flesh. You can't carry it. Or you can't carry gum, or you can't carry durians.
And you'd have a hard time carrying durians, but
Yeah, they're quite large.
they look like massive conkers.
What's a conker? Massive conker? What?
Horse chestnut.
Oh. Oh wait, there's a game called Conkers? Excuse me?
No,
Yeah, it's a traditional. Look at this, dude. It's a traditional game played in. They said, in Great Britain and Ireland, played using the seeds of horse chestnut trees. Oh.
I meant pay more attention to the green stuff.
Oh, I see. Yeah, the enclosing thing. Oh,
The
dude,
sort
this
of
is, dude, this is like the OG Beyblade, bro. Like they put these nuts on like on rope, and then they try to beat the shit out of each other's nuts, I guess. Uh-oh. Conkers looks like a game that we would play in gym class and that nobody knows about. Yeah. Did y'all ever play Bloody Knuckles? That was a game I played in high school. You know what this one is?
Is that with the cards?
No, it's with the quarters. So you'd put your hands down, you'd put your knuckles down on the table, and then you would shoot a quarter at the other person. Like you'd slide it across the table, and then the first person to bleed like lost.
Oh no, we took it more directly.
He's like, we just beat the shit out of each other.
well, no, because right there's a card game called Shithead.
Oh, okay.
I swear to God, and I can't really remember the rules because it's been like 30 years. But yeah, basically whoever loses, they get the whole deck of cards dragged across their knuckles.
Oh no! Oh, that would hurt.
It's
Ew,
like, you're a shithead.
That's the death of 1,000 paper cuts. Ugh. Anyways, I'm sure none of this happens in today's school because the lawyers would get involved and someone would get like sued.
Not in the north. They can barely speak English up here.
Well, over here in the US they would. Yeah. Anyways, let's see. We got another question coming up. A bottle filling machine. Ooh, quite relevant because we have bottles right now. That's cool. On average, 20,000 bottles a day with a standard deviation of 2,000. If we assume that the production is normally distributed and that a year comprises of 260 working days, maybe in like France, definitely not in the U.S. Dude, I think like in the U.S. it's like 364 working days out of the year. Calculate the approximate number of working days that under 240 bottles are filled. Oh, okay. Over that many are filled, and between that number are filled. Oh, wow. Oh, this is actually quite tricky, actually. 52 weeks times 5 minus 5 days of vacation. Yeah, that's all you get. Yeah. Do I have to do a confidence interval for this? I feel like I do. Okay. Yeah, let's do it this way. Or I don't have to do one. Okay.
I don't know if you'd love it or hate it here, but the government mandates that every worker must have 5.6 weeks off a year.
Oh, that's pretty dope. What is France?
Probably is higher.
Yeah. Okay. 20,000. Standard deviation of 2,000. Okay. You said you can use a calculator to do this question? Yeah, well, you have to have a calculator to do this question. That or you're going to start using a table. Okay. I think what we're going to do is we're going to find percentages is what we're going to do. You tell me if this is correct. So, for instance, if I wanted to know how many days that I produce over 20,000 bottles a day, that would be 50% of the days. So 50% of 260 would be 130. I think that's what we're going to do. We're going to find the area underneath this normal curve for the specific like ranges we're looking at. And then we're going to multiply that percentage by 260. Someone can probably tell me that this is wrong. Because statistics always has like so many like weird finicky rules on it, but I'm pretty sure it's okay. Someone else says a better grasp of statistics, please let me know. I guess this is probability technically. Oh yeah, we definitely have to use the standard deviation. Oh yeah, don't worry about that. Oh, we're 100% using that. Okay. I'm good? Okay, thanks, Jeff. As long as Jeff says I'm good, then I think everything's great.
Nice.
Okay. All right, so under 18 240 bottles are filled. Okay, so what we're going to do is we're going to figure out like where that is on our normal distribution, which 18 240 is probably like right here. Okay. And we're looking for under that, so I want to know what this percentage is. Okay. The way to figure this out is to do a z-score. Okay. So I can calculate a z-score for this, which is always going to be equal to the number I'm looking at, which in this case is 18,240, minus the mean, which in this case is 20,000, divided by the standard deviation. Right, the standard deviation is 2,000. You got 16% just already, or standard deviation is 2,000. Or well, I mean, let's try to do this. I think the calculator can actually do this as well. Let me show you. Do you get a TI-84 on your tests, Aduki? So here, we can show you one way to do this, which would I would literally calculate the z-score. I would divide this by 2,000. Gets me a z-score of negative 0.88. Okay. And I don't know. Maybe this is different on the AP exams today, but like we used to have to use a z-table. Sensation, you ever seen a z-table before?
On here, perhaps, not in real life.
Not in real life. Yeah, it's not a very real life thing to do, honestly. But here, let's pull one up.
I shall look it up.
Oh, yeah. Do you have it in your statistics book there? Thanks for the follow, Strafe Godflex. What's up, dog? Okay, yeah, this is a table that shows you for different z values what the area is. That's what this is. Okay. So what you end up doing is we look up this z value, which is negative 0.88, and we're going to look it up here. How you read these tables is this column tells you to like the 10th place, or this row tells you to the 10th place, and then these columns tell you to the hundredths. So negative 0.88, that's going to be in this row, because this is the negative 0.8. And then we need the 0.08 column to get the next one. So that's here. So here's the 0.08. So like pull it down. Okay. So that tells me 18.94%. So that's actually a little bit different than what you got, Aduki, right? 18.94%? And it shouldn't be that far off from the exact. These z-tables are pretty accurate. So that's 18.94% of the days. Okay. So let's look. Yeah, well, let's see how you can do it on the calculator too. You can do it this way. I think you go to stat. No, it's under distro. Okay, no, second vars. Okay, here we go. This is what it is. Okay. And then we're going to do, I think it's a normal CDF. Yeah, okay, normal CDF. And here we go. So Lower is, yeah, what the lowest is. In this case, -1 times 10 to the 99. That's like basically 0. It's like all the way over the left. The upper, in this case, is going to be the 18,240. And then we're going to put in what the mean is. The mean here is 20,000. And then we're going to put in the standard deviation of 2,000. And that's going to get us, look at that, same thing, 18.94%. That's pretty cool, right? Yeah, let's see. Sensation has like a textbook he's looking at. Ah, okay. Yeah, very cool. Okay. Yeah, converting to the Z distribution. Yeah, this is all correct.
There's only one entry for Z distribution in the
Yeah.
back of the book.
But so you should have tables. If this is any sort of like book, they should have a table somewhere. It's probably in the appendix, honestly. That's where I would guess it would be. Like, it's gonna be way in the back, Sensation. I think it's gonna probably be like way in the back, like the last page or something.
Is that it?
No, that's a normal. What is that? I don't know what that is. I think it's usually in the appendix, is what it is. Yeah, there we go. Yeah. Okay, keep going.
It's just a lot of answers.
Oh, it should be a Z table somewhere. The fuck? Oh, but this is everything, though. Oh, this isn't just a statistics book? It's just math for A-level. Okay, well, that makes sense, then.
Which includes, well...
Which includes some statistics, but they don't give you a Z table. All right, that's fine. I mean, you can use a calculator like this to solve it, but yeah, okay. What does A-level mean? Sensation, you can explain A-level to equity. What does A-level mean?
Advanced levels.
Advanced levels. Okay. But it's like something in like the UK, right?
Yeah, it's the prerequisite to get into university.
Yeah, think of it as like your high school diploma or something, I guess, right?
And the first year of undergrad.
And the first year of undergrad. Yeah, it's kind of a combination of both. Because then you have O levels, which is the one before that, right?
See, this is a weird thing. My mother called them O levels because they were, and then
that's what my mom called them.
They were called GCSEs when I grew up.
Ah, okay.
General Certificate of Secondary Education. So anyway, that 16 is the cutoff point for that, and then you take A levels between 16 and 18.
Right. So yeah, equity, you're right. Basically, math up to calculus. Yeah, I would agree. So, anyways, yeah, you get 14.925 days here. If you wanted to do over 16,370, right? Now we just have to move this thing over. And then here, let's like delete all these ones. We don't want any more of these. Can I delete this, please? Thank you. Yeah. So now this just gets put over here. And then this is 16,370. And you're looking for the area to the right. So that's all this, okay? Which is interesting. That's the same thing as 1 minus the area to the left. Because the sum, right? The sum of all this area and all this area has to equal up to 1. So back in my day, when we used to do this with the tables and whatnot, they would just give you, for instance, one of these tables. And you had to know that, okay, if I'm finding it for whatever, the 16,370, it's giving me this area. So to get this area, I have to do 1 minus whatever this area is to figure out what this is. But, you know, y'all got calculators and stuff, so this is like super nice. Because now you can just go to, what is it? We can go to second district again. Normal CDF. And now your lower becomes 16,370, right? Because that's the leftmost you're looking at. And then your upper is all the way up to the right, which is, again, like 1E99, I think is what they like to use. This is like their way of saying infinity. Okay. And then that gets you 96.5%, okay? So that's 96.5%, which if you multiply that by the 260, should give you 251 days. Or we'll just say 251 days. Okay, where this gets tricky, though, is when it's between two values. This is a little trickier, okay? So again, let's say we're doing this. So now I want it between two different values. And then let me copy this over. Okay. So they want it between 17,024. Right, and this is 20,000. This is called, this is statistics equity. 1704. It's super cool, actually. It's a very, I like statistics. Some people hate statistics. Like Rampton doesn't like statistics. Or no, Noise doesn't like statistics. Yeah. So if we're trying to find, like, between two values, which is like this, a couple ways to do that. So you could either do this amount minus this amount, which would give you this. That's kind of the way to really do it. Or I guess you could do this amount minus this amount. By the end of the day, you want this. Okay. With a calculator, again, it's not very hard because you just put in the lower and the upper and it just gets it right to you, which is like super nice. Yeah, so this is like 17,024 and this is 24,943. It'll do this calculation for you, and that gets you the 92.4%. Which, right, just multiplying by 260 is going to get you the 240 days, equals 240 days. But if you had to do this with a table and stuff, you'd have to get this area from a z-score, and then you would have to get, hopefully, again, it depends on the table. You'd have to get this area from a z-score, and then you'd have to subtract the two areas. So if you were to do this area minus this area, that would end up giving you the purple area, which is the probability between two values. Shantrick says, statistics is good when you have all variables included like in a math problem, but it's IRL, it's kind of a headache because there's so many random variables, which makes the answers an educated guess at best. I agree. Statistics, sorry, is actually pretty subjective. Because a lot of times you're like, okay, but what is the standard deviation? Well, we don't actually know what the standard deviation is, so I have to approximate it. Or I have to use a sample, or... What makes it really cool equity is that, yeah, and why it's useful is it's a way we have quantified something being, like, good enough, or, like, close enough. You know? A lot of times, let's say, for instance, you two wanted to argue who's better at Fortnite, right? And Equity gets 24 kills in a game, and Taco Cats gets 22. You could be like, oh, wow, you know, 24 versus 22. Does that mean Equity's a better player because he got more kills? Or is that 24 versus 22, like, close enough that it's basically random? Like, that they're basically the same, you know? That's where, like, statistics comes into play. Because if we ran multiple games, like you and Taco Cat kept playing a lot of games, the amount of difference that's needed in order for us to definitively say that, like, these two are different in skill level goes down. So if you play 100 games and, for instance, you get 23 on average and he gets 22 on average, we could say, like, oh, with 95% confidence, Equity is better. But if we only play one game, then 23 versus 22 kind of looks like a toss-up. And there's a way in statistics to use math to quantify how many games you have to play for us to be 99% sure or 90% sure or whatever that, like, someone's better than the other person. It's really cool. I like statistics. It's one of my more favorite subjects I like to teach. Oh, these are all the chapters you have to do? Wow, there's kinematics in this as well, and Newton's laws. Excuse me. You guys are doing physics and math. What? Those are really
Two things I should point out. First of all, this is pure,
maths.
not further or higher. Anyway, there's 2 levels. But I was just curious as to whether there's actually anything missing from here that a high school student would learn.
Wow, you go to Diffie Q. That's kind of cool. Where's geometry? It's on the left. Coordinate geometry, graphs and circles. Oh, okay. Yeah, no, okay. That's cool. And you got trig. Wow, interesting. Partial fractions. I love how all of differentiation is just like one fucking chapter. That's hilarious.
Oh, there's 2 sections to the book.
Oh, okay.
So yeah, algebra and functions, trigonometry 2, parametric equations, sequences and series.
Wait. Where's differentiation 1 then? Oh, I see. It's in chapter 8. Oh, I see it. Okay. Yeah, I mean, this is pretty standard.
And then more.
Oh, then it goes more. Interesting. It's interesting that it kind of like dips its feet into statistics and physics with mechanics. That's pretty cool.
It does it all. It's pure stats, mechanics, and then it repeats itself, pure
okay.
stats,
All right, Ace,
mechanics.
yeah, Ace, I'll do your question real quick. And then if 12th is still here, 12th has a question. Yeah, sorry. We've been taking our sweet time today. I've just been hanging out. Just been hanging out with you guys. It would be cool if it had sequences and series in it as well, is what I would say. That would be the other
sequences
thing.
and series is GCSE.
Interesting. So that's below A levels?
Yeah.
Oh, fascinating.
I did sequences and series.
Oh, fascinating. Well, you did like geometric series and whatever, but in calculus, sequences and series is more advanced.
Unless it's in higher.
Yeah, maybe it's in higher. Equity says, when the forecast says there's a chance of rain, doesn't it mean it will rain, but the area that will receive the rain depends on the area? Yeah, for sure. Yeah, it just means it'll rain somewhere. But rain doesn't happen, like, contrary to popular belief. When it's raining here, it doesn't mean it's raining everywhere else. I know what you're talking about. Like, if the city gets, like, a % chance of rain, it's actually pretty likely that only parts of the city actually get wet. It's very cool to see, actually. You can see rain happening from far away if you're in, like, a flat enough area of land. Okay, let me do aces before he's got to go. Hollow tube chimes are made of metal and are open at each end. Ooh, open. Okay. These columns resonate best at their third resonance length. One chime is 2.5 meters long and has an air temperature of 25 degrees Celsius. What is the speed of sound? I'm going to assume it's 343 meters per second, but I know there's technically a formula for this. Yeah, rain in your area, not the chance of rain happening as a whole. Yeah. What's the equation? Oh, it's 331. Okay, interesting. Okay, cool. All right, whatever. There's a formula for that. 331.4 plus 0.606 T. I assume this is in centigrade, not in Kelvin. Yeah. It's times 25. Okay, so it's 346.55. So I was wrong here. I think 343 is probably at 20 degrees. Oh, no. Not 30% of the area receives rain. No. It means that rain will happen somewhere in the area with a 30% chance. What's up, dude? What's up, Taco? What is the wavelength of the sound produced? Okay. I have to, like, go up with a little diagram. Open, harmonics. Yeah, here we go. I assume they're talking about like the third harmonic. Oh, I want this one. It's interesting that they said the third resonant length. I think they mean the third harmonic is what they mean. Skibbity toilet, what's up? Did you guys see, do you know what the Oxford word of the year is? Sensation, do you know what this is? The Merriam-Webster word of the year is?
No.
You want to guess what it is?
I don't know it.
You don't know? It's brain rot. Yes, Shantrix, it's brain rot. I am glad it beat out Brat and Demure at least. Like, I would have been mad if it was either one of those. Brain rot, I think, is great. Yeah, brain rot's fucking great.
That's
You
weird.
can use the pic in the PDF I sent. Where'd you send me a PDF? Oh, you put it in the screenshots, maybe, or whatever. Okay. Okay. So third harmonic. So that means you have 3/2 of a wavelength inside the column. Because look, this would be a full wavelength, right? Peak to peak. That's one full wavelength, and then it goes down to the trough. So that's another half a wavelength. So the chime is 2.5 meters long. So I say 3/2 lambda is equal to 2.5, and 2.5 is 5/2 of a meter. Good. So then you can, cancel the 2's out. So lambda is equal to 5/3 of a meter. Cool. So that's the wavelength. Then what's the frequency? Okay. So the relationship here is that lambda times f, or I don't know. Does your teacher use nu? Sometimes they use this for frequency. I like f. Okay. V equals f. Yeah. Okay, good. So it's lambda f is equal to velocity. Yeah. Well, no, so frequency can also be written as this, as like script V, but then that gets confusing with velocity. Yeah. Okay, so yeah, so then we just gotta do some little math. So what's that? So then frequency is velocity divided by lambda. So what is that? 346. So this number divided by 5/3, which is equal to 208 hertz. That's a very low frequency. Wow. I mean, not super low. It's about, most subs are like 100 hertz, so it's like slightly louder, slightly higher than a subwoofer. It's probably like a low kick or something. Anyways, cool. Good question, Ace. I like that one. That was a fun one. Why do monitor frames measure in hertz? That's cool. So that has to do with refresh rate. So that means, okay, because frequency is equal to cycles per second. That's what a hertz is, okay? So when you see a monitor that says it's running at 60 hertz, that means it is refreshing the screen 60 times in 1 second. So that's like... It's also why when you're playing video games, if your FPS is higher than the refresh rate on your monitor, you're not really going to notice it. Because 60 hertz is the same thing as 60 FPS. Yeah. So, a lot of times there's also something called, you've probably seen this in video games, called VSync. So what VSync does is it syncs the FPS of your video game to the hertz of your monitor. So if you have a 100 hertz monitor, your game will try to always produce 100 frames per second. So yeah. Yeah, so that's why it's important. Like, this happens a lot. You guys will get like the latest Xbox Series X or the latest whatever, but you're using it with a 60 hertz screen. you're not going to see any difference really. Or at least frame wise you won't. The textures probably look nicer, but yeah, the general rule is you want the refresh rate of your screen to be higher than like what the FPS of your monitor of your video card can put out. Yeah, you never knew that? Yeah, that's cool. All right, 12. Here, let's do yours. You asked a good question here, 12. Yeah, so check your refresh rate. I mean, a lot of TVs are 60. Some of them are 30, like, if they're really old. But a lot of TVs are 60. The newer ones may be 120. And that's what I think the Xbox Series X does. And actually, it's... Okay, so Ace says, I have a 60 hertz monitor, but I play around 100 FPS. Okay, so you are not going to really notice the 100 FPS. And what you're doing is you're basically wasting power. Because your video card is working harder than your screen can actually display. Yeah. Technically, you can see a difference. Like, the pro players can see it, but not really. And actually, it also depends on the resolution. So, as you go up in resolution, so as you look, as you have more pixels on your screen. So, for instance, this is the difference between 1080p and 4K. It becomes harder to push that many pixels at a fast frame rate, right? What happens when you play on cloud gaming? So, that's a good point. So, yeah, because I just did this. I bought GeForce now for, who did I buy it for? Ace. I just bought it for you, right? I believe they only do 60 hertz or 60 FPS. Let me see. Where is it? Oh, they go up to 130. Oh, wow. Okay, cool. Ultimate members can get, okay, so yeah, so this is a cool thing, actually. So again, it depends on the frame rate and the resolution. So, yeah, so for instance, so if you're doing 4K, you can get up to 120 FPS, which means you would only notice that on a 120 hertz monitor, which most gaming monitors will go up to 120. I think this one goes up to 165. You can like overclock some of the monitors if you really want to. But if you decrease the resolution down to 1080p, so things aren't going to look as sharp, they're going to look kind of blurrier, especially on bigger screens, you can go up to 240 FPS, which is what, yeah, competitive. This is what like the CSGO and like real, cracked out people play at. They play at these super high frame rates. I'm totally cool with like 100. For me, like 100's great. If I can get 100 frames and my monitor's at least 100 hertz, I think the game looks fine to me. But some really competitive people want the because if you're running at a higher frame rate, you're gonna notice changes in the game quicker. Because when someone moves, there's a more likely chance that the frame will catch that movement versus having to wait for the next frame to catch it. Yeah, it's cool stuff. But yeah, you should try to get a monitor that's like at least 100 hertz. I mean, they're not too expensive. I mean, let me think. Yeah, if I go to like Slick Deals, they probably had some gaming monitors on sale. Right, can I please go to Slick Deals? Yeah, let's see. Probably got some gaming monitor. Let's see, like. Yeah, here you go. Look at this. So this is a 27-inch. FHD means it's, is that 1080p? Yes, it's 1080p. And this one is 100 hertz. So, as long as your game isn't running too much over 100 hertz, you're going to take full advantage of what it is. And for $90, that's like really cheap. The issue is I don't like playing 1080p at 27 inches because I feel like that's kind of the limit for 27 inches. So as the screen gets bigger, you want there to be more pixels. Otherwise, you're going to notice like the jagged edges more. And I think the sweet spot for 27 inches is what's called QHD, Quad HD, and that's 1440p is what you want for 27 inches. So again, this right here, this is what I would buy. I would buy this monitor, except that it's mono price, but this one is 1440p, 240 hertz. Wow, that's fast. I wouldn't use this because my video card can't pump out 240 frames at 1440. I could maybe do that at 1080, but not at 1440. Yeah. Anyways, yeah, cool stuff. But it's all related to science, right? Oh, look, physics. All right, cool. 12. Let's help you out with your question real quick. Find the length of x to the nearest tenth of a centimeter. Interesting how they spell centimeter here. Okay. I see triangles. I like triangles. Oh, I think I know how we're going to do this. We're going to use trig functions. 12th. If I can figure out what this is, then I can figure out what this is. It is a cosine sine problem, exactly. So we know this is also a right triangle, which is nice. This is also a right triangle. Okay. What we're going to do is we're going to use this right triangle, this pink one right here, to figure out what this side is. Okay. So, looking at a triangle, are you allowed to use trig functions? I hope you are. I don't know if there's a way to use this without trig functions. But if this is the angle, this is going to be my adjacent, and this is going to be my opposite, okay? So what trig function uses opposites and adjacents? Soka Toa or Soka-tua. Tangent, yeah. Yeah, this one. Okay, so I can say the tangent of 26 degrees is equal to the opposite. I don't know what that is. Over the adjacent, which is 13.8. We can then move this 13.8 over to this side to solve for the opposite. Okay. So I mean, okay, cool. Opposite is equal to, let's get it on the calculator. Also, always make sure that you're in the right mode. This is degree mode, which is good. So this is 13.8 tangent of 26. So that's going to get me 6.73 meters. Okay, that's what this side is. Okay. So now I have this triangle. Where this is 43 degrees. I don't know what this is. And then this I know is 6.73. So this is again another tangent problem. Because now I'm going to say, okay, cool. Tangent of 43 degrees is equal to 6.73 over my adjacent, which is x. Sometimes students get like kind of messed up with this. But we're going to like put this over here. Put this down here. So we put it over here. And we put this down here. Now we can solve for x. And that's going to get me, what's that? That divided by the tangent of 43. Which gets you 7.22 meters. Nice. Yeah, you're welcome, dude. Nice. Ooh, Abhay is a good question. What's up, Abhay? Let's see Abhay. And equity. Okay. Ooh, I like this. Here, equity. You want to learn a little? This is physics. It's actually the right-hand rule is kind of what this is. Okay. So, part of an electric coil is shown below. Oh, here, let me make sure I tell Bob that we doing yours. If he's around. So, an electric motor shown below where the current flows from B to A in the coil. Okay. So, current's really doing this. Yeah, what's up, dude? Very good. So this is kind of what current does. Yeah. All right, cool. All right. After a half turn of the coil, which direction does the force on the side AB point? Okay. Oh, and these are two parts of a magnet? I don't know if you can have this. I don't think you can have just like this is north and this is south. That's like a magnetic monopole, which is like not allowed. Interesting. Okay. Well, if we assume that there's a north and a south side here, it wouldn't just be a magnet doing this. Then this is the direction of the B field. So B fields always point from north to south. That's what we say. Okay. A half turn of the coil. So that means it's now over here on the CD side, I guess. Is that what we're saying? So like this like comes looped around. Right, okay. So if this rotates half, then now the current's flowing this direction, and this is B, and this is A. Okay. So what we just say is that F is equal to I L cross B. Okay. Where L is also like the same direction that the current is flowing, and then B is the direction of the magnetic field. So if we were to set up a coordinate axis here, okay, or here, let me do it this way. I'm gonna say this is X, this is Y, and this is Z. Okay. The B field is pointing in the positive X direction. Okay, this is the B field, which is in the X hat direction. And then the current is like coming down this way, so it's coming this way. So the current is in the negative Y direction. So they say this is the current, which is in the negative Y hat direction. Okay. I don't know if you've done cross products before, but the way to do this is you can use this, which is the right-hand rule. Here, cross products. Where is it? Okay. So what you do is you take your finger like this. Okay. Oh, let's get rid of this. A points in this way, B points this way, and then A cross B points up, okay? Where this is A cross B. It's like the torque hand rule. It is. It's very similar to it. And so what we have is the current is in the negative Y hat direction. So I have negative Y hat, which is A, is crossing with B, which in this case is B. So that's crossing with the X hat direction. And I want to know what this is. Like, what direction does this point? So, if we were to take our hands here, right? And point my pointer finger towards me, right? My middle finger here, which is the B part, kind of points, like, away from me and to the right. Then I see that my thumb, which is the cross product of it, points up, which is in the Z hat direction, okay? And so the answer would be up. If you don't want to do this using like things with your hands and stuff, but you should get used to this because this gets used a lot in physics. There's some rules for doing the different coordinates, okay? And it kind of runs like a round robin. So here's how it goes. So like x cross y is equal to z. And then if we move them, so if I move this one over here, move this one over here, and then move this one forward, I get that z cross x. I should really... Here, let me put these... Yeah. Z cross x hat is equal to y hat. And then again, if I move them around again, it's kind of like a merry-go-round, is what I say. Y hat cross z hat is equal to x hat. Okay. Do you see how this works, Equity? Do you see how like this one just like moved forward here, this one moved forward here, and then this thing like came around to the front. And then the opposites are also true. So if you flip these, so instead of saying x cross y, if I say y cross x, that's equal to negative z hat. Okay? And then you can move the minus sign around places, is what you can do. So, and then also, right, yeah, z hat, so x cross z hat equals negative y hat. The cross product, my nemesis! What's up? Good to see Zach. Yo, good luck on your, Wait, it's not tomorrow. It's Thursday. Thursday's your defense? I think it's Thursday, yeah? Good luck on your defense. Good luck on your defense. I'm gonna keep wishing you good luck every day. I thought it was tomorrow. It's Thursday. I know it's Thursday. Yes, Thursday. Yes, you're very good, dude. Yeah. I'm excited, dude. I'm excited for you to join the PhD land. Ba-ba. Are we gonna call you Dr. Zach? Can we call you Dr. Zach? Or Dr. E to the 2i pi? I think it'd be pretty cool. Is there a PhD land? Yes. They promised me one. That's why I spent 10 years in it. I spent 10 years in that degree program. Trying to go to the PhD land. Right. So here, yeah, look at this. So we had negative y cross x. So that looks like this one. Y cross x would be negative z, but because there's a negative on this, you put a negative on both sides, and then you get y cross x is positive z. So does that kind of make sense? How that works, Equity? Like if you don't want to do this, you can strictly look at what the components are and figure it out. Anti-commutative. Yeah, exactly. Yeah. It's kind of confusing. Yeah, it's okay. We'll get to this. This is kind of more vector calculus is what this is eventually. But basically, like, certain things in nature react at, like, right angles. So, like, if something does this and then something does this, it creates something else which is at a 90-degree angle to both of the things. So, for instance, the coordinate plane is like this. This is actually pretty cool. So, for instance, if you have something in the x direction and the y direction, let's say something's going in x and something's going in y, something that goes in the z direction is 90 degrees to the y, but it's also 90 degrees to the x. This is called orthogonal to both y and x. Which I have to remember what the difference is between this and orthonormal. I think orthonormal is 90 degrees, but also... what is it? What's the difference? Yeah, there you go. Okay, so orthonormal is if they're orthogonal and each vector is a unit vector. Thank you. Okay, thank you. Yeah. Well, it's weird that normal means unit length, because normal usually means 90 degrees, right? Which is also ortho, at least in physics land. If we talk about the normal force, that's the force that's 90 degrees or perpendicular to the surface. Yeah, no. Yeah. No, yeah. It's weird. Normal. Yeah. It should be ortho unitary. That's what it should be. Right? No, you're not wrong. Norm equals normal. Yeah, this is what they say. Yeah, it's pretty cool. Anyways, yeah, good question there. Yeah, nice. Good job there, Equity. All right, let's see. Bro, is this... Oh my god, is this one of like Fermat's last theorem or something? Dude, Zach, take a quick look at this for me. Real quick, sorry. Just tell me if someone's like trolling me. Because people sometimes just give me questions where I'm just like, what? Each of A, B, and C is equal to a number from the list. 3 to the 1, 3 to the second, 3 to the blah, 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 and so forth. There are n triples for which A is less than B is less than C, for which A times B over C, and... It's from the 2024 Pascal. Ooh, okay. I feel like I've seen this before. Sensation, throw your batteries in the sea. Yeah, it's a competition problem. Well, each ABC is equal to a number from the list, so it's 3 to the 1 to 3 to the 8th. I think the 3 to the doesn't really matter, right? What you need is you need the powers on the top to be greater than the power on the bottom, right? Because that's how you get an integer, I think, right? So let's say, for instance, I had 3 to the second times 3 to the third over 3 to the first. That's 3 to the 5th over 3 to the first, which is equal to 3 to the 4th. N equals N, done. Tautology. What's up? Yeah. So I think this is the requirement. So like A plus B must be greater than C. A plus C must be greater than B. And B plus C must be greater than A. Which, isn't this the triangle inequality? I think this is just the triangle inequality, right? Like, the sum of two sides always has to be bigger than the third side. And I have 8 different lengths I can have, right? Oh, and look, A has to be less than B has to be less than C. Okay. Is there a fast way to do this versus like brute forcing this, right? Because I know that 1, 2, 3. No, it won't actually, because 1 plus 2 is... Well, actually, but they can be equal to each other. Sorry, they can be equal. Which one is the most restrictive? So it's not exactly the... Well, no, it is a triangle inequality. Wait, is it? No, it's not. I did it by brute forcing it, and it looks like it took like 25 minutes. Yeah, we don't want to do that. Which one is the... Oh, I like this. Yeah, good pen center. Which one is the most restrictive? The most restrictive is this one. Right? Because A and B are the smaller ones compared to C. Right? And yep, I'd start there. Okay, cool. So, okay, 1, 2, 3 works, right? And then that's it. I guess you could do 1, 3, 4. 1, 3, 4. 1, 4, 5. 1, 5, 6. 1, 6, 7. 1, 7, 8. They can be equal. Oh, interesting. Oh, that's a bitch. Really? I would think they could only be equal to one of the numbers from the list. Also, the answer has to be 0 to 99 inclusive. Okay. Also calculate the mass of the... You guys are hilarious. Also, in order to invent the universe, you must learn how... In order to bake a pie, you must first invent the universe. Is that what it is? Man, because if they're equal to each other, right? Then, like, does 1, 1, 2 work? Right? And then 2, 2, 4. 3, 3, 6. 4, 4, 8. That gotta stop. Sometimes we can see these by seeing a pattern. So, for instance, like how many solutions do we have for 1 being the first? Right, that was 1, 2, 3, 4, 5, 6, 7. So we had 7 solutions. Let's see if there's a pattern. So, for instance, we could have 2, 3, 5. 2, 4, 6, 2, 5, 7, 2, 6, 8. And then also the double of 2, 2, 4. Right? So how many solutions is that? That's 1, 2, 3, 4, 5. That's 5 solutions. So you could have 3, 4, 7, 3, 5, 8, and then you're stuck. And then you just have 3, 3, 6. So now you only have 3. And then, oh, 4, 5 doesn't work anymore. I'd fix the C and do patterning, but I like this approach, yeah. Yeah, and then we can't go any higher, right? Because, like, I can't do 5, 6, 11. Okay. I think we're done. Are we done? I want to say we're done.
Nice.
I feel like we'd be done here. Because, I don't know. And then I have these two. Right? Yeah. C is my first number. I guess it is. Oh, there's a solution? All right, let's see. Let's check the solution. Which one was this? Oh, here we go. Okay. The answer is 86. Oh, God. T is less than R plus S. Oh, I was doing it backwards. Wait, what? One sec. B plus C minus A equals A plus C minus B equals A plus B minus C. Huh. Oh, okay. Yeah, no. RST is greater than or equal to it. Oh, I did it just for it being equal to it. I see. And then they set the first number, pen is what they did. Yeah, very cool. Okay. 86, man, dude, that's well, yeah, obviously this is the last question on the Pascal thing. But yeah, I liked our approach at this. Pen was right. Yeah. Looking at these is the key thing. The fact that it's 3, we don't care about the 3. We just care about the exponents. Anyways, cool. I like that question. Those are fun. Fun little brain puzzles. But yeah, there's a general process you can go to solve these, which is, yeah, like what Penn was saying. You fix one of the values and then just go through all of them. Yeah, you do. You ignore the BC over A and the CA over B. I like that, Penn. Yeah, I didn't think of that. Of like which one is the most restrictive. Exactly. Yeah. It's because A and B have to be less than C. Then I care about the one where I need the exponent on the top to be A and B. Because that has to be greater than C. But that has to also be the lowest numbers. Yeah. Cool. What's up, Skeeg? Yeah, nice. Okay, cool. Those are good questions. I don't think we have any more today. Pen, are you streaming today? No, not this. Was it? Yo, what's up? Yo, Enigma, what's... is your bot down, by the way? It's sad, dude. I hit Chads and nothing happens. Yeah, I process those on like Sunday. Don't worry. I do all the channel points. Oh, Zach's on in 30 minutes. Oh, man, I gotta teach soon. Fuck. Alright, good to see you, Shantrix. Yeah, nice. Yeah, also, yeah, be sure to follow all the other awesome Mash streamers we have here. A couple of them are in my chat right now. And then also, if you want to find out when they stream, we have a calendar right here. Which has everyone on. Can you add the 1,000 bond coins you owe me? I do owe you 1,000. Yeah, Enigma, yeah, let me know. I was trying to use the bot today, but it was kind of messing up. Okay. Anyways, all right. I don't think we have any more questions today. I have to go teach another student, so let's close out the stream. All right. Thank you, everyone, for coming out to Education Off Hours today. I had a fun time working with all you guys. Appreciate all the questions. Our next stream is going to be tomorrow. That'll be at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. Oh, you do have a question? Oh, I like that AAA. The surface area. Ooh, that's a good one, actually. That is a good one. I do like that one. Ask that. Okay, so here's a good thing here for you, Skeeg. The Decem beard gold. I've had a beard for a while here. But yeah, so here you go, Skeeg. If you want to, this would be a great question for either the 2iPie to go over in his stream. If he's streaming today. I know his defense is coming up soon, but he may be streaming. But if he is, here's a shout out to our boy. to e to the 2y pi. No. E. But yeah, he's going to be streaming in like 30 minutes. So if you want to ask him during his stream, he can help you out with that one for sure. But not Thursday. Yeah, because we got to be celebrating. We're going to celebrate. We're going to celebrate you, Zach. We're going to celebrate you on Thursday. Okay. Anyways, yeah, our next stream will be tomorrow. Come on by. Meanwhile, is anyone else that we know chatting? High potential, Merryweather. Okay, cool. We can go. As long as Merryweather's not talking about hag maxing.
Number, and date and manufacturer.
All right, cool. All right, let's go say hi to Merryweather for a bit, and then yeah, please go over to Zach's stream in 30 minutes, and he can help you out with all sorts of math and science stuff. Cool. Okay, awesome. Have a wonderful rest of your Tuesday. Enjoy the week. We will see you tomorrow. Peace. Bye, Pen.
Some people might complain that, like, oh, why go through the effort? And I'm like,